Progress in the development of the Atlas weapon system was significantly advanced in all areas during the third quarter, 1959. Problems encountered with the D-series missile during the previous 3-month period were resolved in the test labs. The resulting modifications to systems and components were proven out in static tests at Sycamore Canyon and in the flight test program at Cape Canaveral. General Dynamics personnel at Convair Astronautics will report on highlights in the overall program.
During the past 3 months, progress in manufacturing development was highlighted by the scheduled increase in production and completion of the move into new facilities. The new office building was occupied in August. This building and other facilities acquired by General Dynamics represents an increase of 153,000 square feet in floor space during the 3-month report period. In the factory, Missile 48D was placed in Dock 18. This is the latest of 4 new docks to be activated for final assembly operations. 2 former assembly areas have been converted to missile checkout docks, increasing the total to 9. A highlight of the quarter was completion of several missile composite systems tests on 30D, the first missile equipped with all-inertial guidance. This is an engineering article, a test bed for Series D AIG and E-series missiles. During a composite test, near-flight conditions are simulated. Simultaneous operation of missile systems during one of these tests permits evaluation of overall missile performance. The distinguishing feature on 30D is the new AIG pod, which contains the missile guidance set. This armor Bosch unit continuously computes missile velocity and position from launch throughout powered flight, but does not actually guide the missile during the booster phase. During the initial power boost, the missile is controlled by the Convair autopilot to a programmed flight path. At staging, initiated by the inertial guidance system, the booster engines are cut off and separated, and guidance switches to IGS. The IGS then controls the Atlas throughout the sustainer and vernier stages, cutting off engine thrust at the proper time to place the re-entry vehicle in the proper trajectory to the target. Missile 42D is the first all-inertial flight test article scheduled for launch from Cape Canaveral. Fabrication of Missile 1E began early in the quarter. The bulkheads for this new series missile were constructed early in July. The tapered tank section was moved to the major fixture area in mid-August, where remaining skin sections were added and bulkheads installed. These skin sections are made of heavier gauge steel, needed because of the greater propellant loads, increased engine thrust, heavier payload, and quick start capability of the E-series missile. The completed tank section was placed in the final assembly dock on September 28th. Build-up of the E-series propulsion system test article was also started this quarter. The new Rocketdyne MA3 engines differ considerably from former Atlas propulsion systems. The booster engine, which formerly used a single gas generator, has been repackaged to include a separate gas generator for each turbopump assembly. With separate booster engine installations and removable external fairings, accessibility has been improved and maintenance simplified. Both boosters now produce 165,000 pounds of thrust, an increase of 30,000 pounds over the MA2 booster. The sustainer thrust chamber is basically the same as the current MA2, with exception of heavier wall tubes in the combustion section. Turbine exhaust is routed through an exhausterator. Thrust is rated at 57,000 pounds. Vernier engine operation has also been simplified. The verniers are signaled to start after the sustainer engine, eliminating the former pre-run tank-fed operation. This thrust structure will be erected at Stand 1-4, Missile Static Test Site, Edwards Air Force Base. New manufacturing methods and tools have been adopted to keep pace with advanced series missile production. This is a radial stretch former, largest in the United States. Here, the 9-ton machine stretches stainless steel stock for the pie-shaped gores used in bulkhead construction. Quality control of large metal stock is now maintained by a new ultrasonic sensing device. Material is submerged in the test tank and is scanned automatically to detect flaws. The manufacture of electronic components kept pace with new requirements for DAIG and E-series missiles. Simpler and more accurate manufacturing methods were adopted for the assembly of these components for the new autopilot package. Workers build up the various circuit boards from raw stock, adding circuitry and electronic parts in assembly line fashion. After completion, each unit is tested automatically. Following this, the assembled components are installed into the package. Circuit boards can be easily removed and replaced, providing greater accessibility than former canister versions. 4 separate packages make up the unit and are located in the missile's B-2 equipment pod. They are the gyro package, filter servo amplifier, electronic programmer, and excitation transformer. Accelerated production schedules have been maintained with the adoption of these new manufacturing and checkout methods. Facilities at Convair Plant 2 were used for the fabrication of a prototype E-series launcher. This is a captive test version slated for installation at Sycamore Stand 2. The launching concept for Series E missiles is referred to as a free launch type. Simplified and less costly, this launcher has no hold-down provision. The launcher frame supports the erector boom and is hinged to the launching pad. Erection is accomplished with the missile mated to the launcher. After erection, the missile stands free, resting on 4 pedestal supports ready for launch.
In the test lab, we have continued evaluation of design improvements, along with normal testing of D&E series hardware. At the gas flow laboratory, pre-production tests were run on the Convair-developed liquid oxygen boil-off valve. Relocated atop the forward bulkhead, the valve is slightly larger but less complex than former models. The boil-off valve senses tank pressure and vents the boil-off gases to maintain proper pressure. Gaseous oxygen is released and vented through the ducts away from the missile. Complete system tests were carried on at Point Loma facilities. In Tower B, the propellant flow test article was modified for E-series testing. Dual liquid oxygen elbows were installed and new plumbing added. The E-series fuel and liquid oxygen flow test program will begin in October. Thermodynamic tests were run in C Tower on a Series D thrust structure. Heat banks were set up around the test article to simulate aerodynamic heating prevalent during the missile's flight through the atmosphere. Booster and sustainer thrust loads were also induced by hydraulic rams to further duplicate structural loads on the fiberglass fairing. Enough electrical power was consumed during the test to light 500 average homes during peak loads. No structural damage was recorded during any test, though temperatures reached a high of 500 degrees. At the environmental shroud, the IOC missile handling trailer underwent environmental testing. The operating mechanism on the trailer will run through proof cycles at temperatures ranging from 65 degrees below zero to 160 above. This nose clamp successfully demonstrates its operability under any weather condition.
Here at Sycamore, B-Series
components, and systems were tested in a near-fight environment.
On July 2nd, the first multi-stage firing of 9D was run successfully at Stand 1. 11 days later, the first full-duration firing was accomplished. These tests satisfied all of the requirements for the first block of tests. This block consisted of a series of objectives to prove out the compatibility of missile-borne systems, structural integrity, and propulsion system performance. More refined test objectives were set up for blocks 2 and 3. Of major interest was the performance of the Acoustica propellant utilization system. The design criteria and philosophy of the system were substantiated during the remaining firings. With Missile 9D, the following engine run times in seconds had been accumulated. Booster, 724. Sustainer, 1,050. And Verniers, 1,127. Planned test objective satisfied, 9D was removed from Stand 1. Prior to missile checkout in Stand 2, technicians checked out a major portion of the instrumentation while the missile was in storage at the site. Slippage of the test schedule was minimized by this action. The rework on the stand was completed July the 14th, and 4 days later, Missile 24D was erected. On September 2nd, the first full-duration staging run with 24D satisfied all requirements for the first block of tests. Block 2 opened with a successful run on September the 18th. Interest was centered on the remotely activated primary battery, which operated as planned. Run 405 was the last firing of the quarter. Performance of all systems was satisfactory. Total engine runtime accumulated for Missile 24D during this quarter was Booster, 447, Sustainer, 797, and Verniers, 854. The last 3 runs were each preceded by uninterrupted countdowns.
There are 3 types of Atlas developmental activity underway here at the Edwards Missile Static Test Site. Stand 195 was the site for 14 simulated operational missile loading tests during July and August. In the last run of this series, the light skin test article was loaded with propellants and gases in 12 minutes. These tests resolved that certain changes would increase the rate of fill. These changes were approved for incorporation in all missiles beginning with 33D, in addition to IOC missiles at Vandenberg. Conversion of Stand 195 for the centrifugal pump test program began in August. The program is scheduled to begin in October. At Stand 11, the operational propellant fill and drain system was installed. This was accomplished prior to the erection of Missile 37D on August 31st. This missile is slated to undergo a series of tests to investigate the fatigue life of propellant tanks and ducting when subjected to operational temperature, pressure, and tank detank cycles. Preparations were underway at Stand 14 for the first E-Series propulsion and missile compatibility test. The battleship tanks were modified to the E-Series configuration. Additional tank volume was required for the larger propellant capacity of this series. Plumbing was reworked and new instrumentation was installed. Tests will begin in January 1960.
A major highlight of the quarter was a successful flight test program conducted at the Atlantic Missile Range. As a result of improvements in missile reliability, major advances were made towards the goal of an operational weapons system. The first Atlas launch this quarter was 8C on July 21st. This was the third attempt to carry an RVX-2 reentry vehicle to an impact point 4,385 nautical miles downrange. Vehicle separation occurred as planned at 282 seconds of flight. Impact was within a 2-mile radius of the prescribed target area. A balloon was sighted in the water approximately 69 minutes after launch, and the vehicle was recovered in excellent condition 63 minutes later. The first successful D-Series flight occurred on July 28th with the launch of Missile 11D from Pad 11. This was the first D missile planned to impact in the Ascension Island splash net, 4,385 nautical miles downrange. An average of all available data placed impact of the reentry vehicle within a 1/2 mile radius of the target. The flight of 11D proved out modifications to correct earlier D-Series flight problems. The second D-Series missile to reach the Ascension Island splash net was 14D, launched at 1 p.m. on August the 11th. All systems operated as planned during the powered portion of the flight. The Mark II reentry vehicle was bumped by the missile during retro-rocket firing. This was attributed to a deflection of the retro-rocket thrust vector due to expansion of the exhaust gases against the tank surface. Despite the bump at separation, all reentry vehicle systems operated satisfactorily throughout the flight, and impact was on target. On August 24th, Missile 11C was launched. A camera was installed along with standard instrumentation in the nose cone. At an altitude of approximately 200 miles, nose cone separation occurred, initiating camera start. At upper left, the missile body falls away. Below, in the center of the picture, is the Florida Peninsula. Cape Canaveral is covered by a triangular-shaped cloud layer. Now, 250 miles above the Atlantic, the camera is making a full circular sweep of the horizon every 2 minutes. The dark areas are water. The white patches, clouds. The long white strip is a storm front moving northeast across the ocean. The arc of the horizon at this point is approximately 2,000 miles across. This is a view of the Earth from a distance of 350 miles. As the reentry vehicle approaches its apogee of approximately 700 miles, the camera photographs the northeast coast of South America at a point where the Amazon River meets the ocean. Re-entry vehicle impact was 4 miles long and 0.6 miles to the right of the target area. The data capsule was recovered intact. The camera had photographed over 1 million square miles of the Earth's surface. Missile 10D was assigned the special task of placing an unmanned Mercury capsule in a given flight path at a predetermined velocity and altitude. The 2,200-pound R&D space capsule, built by McDonnell Aircraft for the National Aeronautics and Space Administration, contained 3 telemetry transmitters, 4 data tape recorders, and 2 tracking beacons. 10D was launched from Complex 14 on September 9th. The flight appeared normal until booster separation. At this point, a malfunction occurred and the unit did not jettison. The booster section stayed with the main body until the capsule separated. The excess mass carried during this second stage resulted in a velocity less than the planned 23,850 feet per second. Impact was 500 miles short of the planned range of 1,809 nautical miles. The capsule was recovered 8 hours after impact at a point approximately 200 nautical miles southeast of Antigua. Post-flight inspection revealed that the capsule was in excellent condition. 17D was the 31st Atlas flight tested and was launched on September the 16th. The Vernier Solo hydraulic power system did not activate at sustainer cutoff, and missile attitude control was subsequently lost during the Vernier Solo phase. The Mark II reentry vehicle was successfully separated with no indications of bumping the main missile body. Impact was 2.2 miles short, with no cross-range error from the planned target in the Ascension Island splash net. On September 24th at Complex 12, Missile 9C, with an Able 4 second stage, was destroyed by an explosion. Loss of fuel supply to the sustainer engine caused premature engine shutdown and failure of low-pressure liquid oxygen ducting. The resulting fire led to the missile's destruction. Work was begun immediately to rehabilitate the launch complex.
At Warren Air Force Base near Cheyenne, Wyoming, construction on pads A and B was essentially complete. The first large piece of Convair ground support equipment to be delivered to Complex 564-A was the launcher, weighing 72,000 pounds. Designed for horizontal readiness, the launcher and erector boom are similar to those installed at Complex B, Vandenberg Air Force Base. Installation was completed by mid-September. A highlight of the quarter was the delivery of the first Atlas intercontinental ballistic missile to Warren Air Force Base. The missile was 34D, transported on an IOC trailer. Both missile and trailer covered the 1,300 miles without difficulty, despite adverse weather and road conditions. The Atlas convoy arrived at Cheyenne on October the 2nd, 5 days after leaving San Diego. 34D was the 14th missile delivered to operational and test sites during the third quarter, 1959.
A significant advance in the Atlas program was achieved with the flight of the first ICBM missile from Vandenberg Air Force Base on September 9, 1959. Atlas 12D was launched from Pad 2 at Complex 576A. In the Launch Operations Building, members of the 576th Strategic Missile Squadron conducted all missile launch activities. A pre-flight missile systems checkout was performed using the automatic program checkout equipment. Decks of IBM cards were used to activate the missile systems. The status of individual components is automatically displayed on a console and printed paper tape. In the control center, group response of these systems is displayed on a status board where thousands of items are checked in a matter of minutes. During the planned 20-minute countdown, the launch control system satisfactorily performed pre-established checkout and event sequencing controls. The operational propellant transfer system completed missile tanking at IOC rates.
At 10:50 in the morning, 12D was launched. During the vertical portion of flight, the first demonstration of the Atlas high-degree roll capability was effected. A 49-degree clockwise roll program was satisfactorily accomplished. All other flight objectives assigned to 12D were completely satisfied. The Pacific Missile Range splash net placed impact of the reentry vehicle 1 mile short and 0.7 miles right of the planned area. Flight range was 3,899 nautical miles. With this event, the Atlas weapon system reached operational capability, rounding out a research and development program of less than 5 years' duration. On the last day of the quarter, 3 more missiles were delivered to Vandenberg Air Force Base.